Graph analysis number 4 is from the 2014 exam. The mean score is 3.26 and it is a no calculator question, as are all of these graph analysis questions. I'm given g of x defined as the integral of f and the graph of f over here. In part A, I'm asked to find g of 3. When I go to my function g, I see that the x is the upper limit. So to evaluate g of 3, I plug the 3 in for the x. And with the graph of f, I just go find the area. So if I'm doing the integral of f, I'm going to refer to f's graph, look from -3 to 3, and find the area. I've got a triangle above the x-axis with an area of 10, a little one below the x-axis with an area of 1, and we know above the x-axis is positive, below is negative, so that gives me a final g of 3 value of 9. In part B, I'm asked about graph characteristics for g. So what that means is I'm going to use a gun chart. If I want to know where g is increasing, so g is increasing where my g prime graph is positive. So I'm looking for where g prime is positive. And g is concave down where g prime is decreasing. So I'm also looking for where g prime is decreasing. Let's go ahead and find what g prime is. If g is defined as the integral from -3 to x of f, then its derivative, used in the fundamental theorem of calculus part 2, gives me g prime is f of x. So this graph that I was given that's labeled f, it is actually the graph of g prime. And I've already decided I need to know where this g prime graph is above the x-axis and decreasing. And that happens in two places, from -5 to -3, and again from 0 to 2. So I just list my intervals out. That's going to earn me my first point. And my reason is g prime is positive and decreasing. Make sure that you reference g prime in your explanation, or you can call it f. Somewhere on your paper, in order to get this explanation point, you must somewhere make the connection between g prime and f. In part C, I'm given a function h that's defined as g of x over f of x. I'm asked to find h prime of 3. I first have to find h prime of x. Because h is a quotient, I'm going to use the quotient rule. And here is my quotient rule. So it's my bottom function as is times derivative of the top minus the top function as is times derivative of the bottom all over that bottom function squared. Make sure you square the 5 as well as the x. That correct quotient rule is going to earn you 2 points. If you miss something like maybe you didn't square the 5 or you have a reversal between the two terms, then you might get one of the two. I'm asked to find h prime of 3, so now all those x's are now going to turn into 3's, and now I just must evaluate this. To find g prime of 3, this is my g prime graph, so I'm just looking at 3. I have a value of -2, so in place of that I'm going to put a -2. My g of 3 is coming out of part A. I was asked to find g of 3 in part A, so I'm just pulling down my answer for my g of 3 value. And once you have those function values plugged in, you are fine to stop right here. In fact, I would advise you to stop here. You're going to earn that point. If you simplify, you would end up all the way down to a -1/3, but going beyond what I have boxed is not mandatory. If you choose to simplify and you do something wrong, then you lose your answer point. In part D, I'm given another function called p, which is defined as f of x squared minus x, and I'm asked to find the slope of the line tangent to the graph of p. So slope of the line tangent just means a derivative, and that just means I'm going to find p prime. So to do the derivative of p, I need to recognize it as a composite function. X squared minus x is inside of my f function, so what that means for me is I need to do a chain rule on this. So p prime of x is the derivative of the outside function, so that's f prime. Leave the inside part alone, so it's x squared minus x, times derivative of that inside function, which is 2x minus 1. I'm asked to evaluate this at x equals -1, so every place I see my x's, I'm going to substitute in a -1. So this becomes f prime of 2 times a -3. I'm given the graph of f above, and so if I want to find f prime of 2, That means I'm paying attention to the slope that's going on at 2. So I need to find the slope of this portion right here. And I can count and see I go down 2 over 1, down 2 over 1. So my slope is going to be a negative 2. So f prime of 2 is negative 2 times that negative 3 gives me a final p prime of negative 1 value of 6. Point-wise, a correct chain rule would earn you 2 points. And to get down to that value of p prime of negative 1 is your last point.